So in this last video for 2.1, we're going to take a look at some graphing. Again, I'm going to do it by hand. You're more than welcome to bust out your calculators to verify our results. But again, doing some stuff by hand kind of gives you a feel for what's happening solution point wise. And what we're trying to do is establish some basic graphing mechanics, if you would. The point plotting idea as well as some basic shapes. To give you an idea, earlier in this module, we graphed y equals x. That is a classic line shape, right? So that was one of the first graphs that we did by hand. The other one we did was y equals x squared, and we found that classic parabolic shape that looked like so. So these are what I call basic function, basic equation shapes. So we have line shapes, y equals x, and we have parabolic shapes, y equals x squared. And it turns out that we have some other basic features. Important to understand the basic features because later again comes some future chapters, chapter 3 I believe it is. We're just going to take these basic shapes and shift them left, shift them right, shift them up and down, rotate them around, all kinds of stuff like that. So if you know the basic shape, you can basically do the transformation. So that's kind of our goal here. So again, in order to do my graph, oops, I have these totally reversed. All right, let's go ahead and start putting some things in. Again, it's always a good idea to put in a couple of negatives, 0, and a couple of positives. So what happens if I put a negative 2 in there, right? Well, y negative 2 cubed, right, becomes negative 8. Y equals negative 1 cubed, right, gives us negative 1. Right? Y 0 squared gives us 0. Right? Y 1 cubed gives us 1, and y 2 cubed gives us 8. Now, are there a lot more data points? Yes, but here's 5, and let's go see if we can't see the pattern, right? All the other solution points on a graph of y equals x cubed. So we have negative 2, 1, 2, 3, 4, 5, 6, 7, 8, right? So there's negative 2, 8. We've got negative 1, negative 1, 0, 0, 1, 1, and then 2, 1, 2, 3, 4, 5, 6, 7, 8. So this graph kind of has a little ripple in it, right? A little S shape, if you would. Arrows are important because that means that this goes on forever, right? If I was to put it on a 3, we get 27. So notice it's way the heck up there. If I put in a negative 3, we get a negative 27. So it's way down there. So this graph basically goes on forever in the x direction, and it explodes, if you would, right, in the y directions, both negatively and positively. So there is a basic shape of your x cubed graph. So anything involving an x cubed, right, is going to have this little S shape to it. All right, so that is a very classic shape. The next one is kind of interesting because we have the absolute value, or excuse me, we have the square root of x. All right, and what we can, if I try putting something in there that's negative, as a matter of fact, again, let's try putting some nice things that have some nice squares in them. If I try putting a negative in there, right, what we end up with is basically 2i, a complex number. And this, right, is what it's defined to be, but right now what we're trying to do is we're trying to graph in reality. All right, so putting a negative inside here actually is a bad idea if we're graphing in reality. If I was graphing in the complex number system, all bets are on, right? Let's go ahead, let's go for it, and you actually do that. I think like in Math 461 or something like that at ASU, but we're not in 461, right? We're not that advanced quite yet. So we're going to try to geese ourselves and base ourselves in reality, right? And so we basically can't put any negatives in there because that creates a complex number. So starting at 0, the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. So I have 4 data sets. I could go past that, but let's stop there. So this graph actually starts, there's no arrow, right? It actually starts at 0, 0 because negatives aren't allowed. And then the next data point is 1, 1. The next data point is 4, 2, 5, 6, 7, 8, and about 9. Let's just say 9's way out here. So there is an arrow in this direction, because I can actually keep going on and on and on, putting 16 in there, putting 25 in there. And so what we have is the basic shape of the square root of x. It always has it has a limited domain, can't put any negatives in there, and then wherever that starts, we basically have pretty much a laying down half of a parabola, as you'll see in a moment. So there's basically the graph of the square root of x. Okay, so again, point plotting, getting a feel, getting an idea. It's why your graphing calculator will do the same thing. It won't graph anything over here on this side, and the reason being is because we don't want any complex numbers. So what about x equals y squared? All right, so again, what we usually start this with is by putting x values in there. So let me go ahead and try putting some nice ones in there. I kind of anticipating something that's coming ahead. So if I try letting x equal -4, right, we're going to get -4 equals y squared. To solve for y, I'll take the square root of both sides, introduce my plus and minus, and we get basically plus or minus 2y equals y. So in the process of trying to solve for y, right, what ends up happening is we end up introducing a square root, and as we saw in the last example, square roots of negatives, they're defined, right, but we again are graphing in reality. So what this basically means, because of that one little investigation, no negatives allowed. So what happens if x is 0? Well, we get 0 equals y squared, take a square root plus or minus. The square root of 0 is 0. So 0, 0 is one of our data points. What happens when x is equal to 1? Well, 1 equals y squared. Take a square root, introduce a plus minus. We have y is equal to plus or minus 1. So we actually have two data points, right? Let me write it that way. So 1 and plus or minus 1. So we actually have three data points right there right away. If I let x equal 4, right, 4 equals y squared. We take a square root, introduce a plus minus. We have plus or minus 2 as our y. And on and on and on. So let me stop there. We actually have 5 data points. I've got 0, 0 to graph. I've got 1, 1 to graph, and 1, -1 to graph. We're actually symmetric about the x-axis, right? We got 4, 2, and 4, -2, right? If we tried the 9, right, 9 equals y squared, take a square root, we get plus or minus 3 equals y. So 9 would give us 3 and -3 respectively. So this graph would have arrows going in this direction, right? So the square root of x kind of gives us the top half, right? And negative square root of x basically gives us the bottom half. That's essentially what's going on here, right? It's plus or minus, right? Square root, square root. So there's basically two graphs we have to graph. Positive square root of x, which is the top half, negative square root of x, which is the bottom half. Of course, we got there by just doing some number crunching. All right, and so there's a graph of x equals y squared. All right, and so another classic shape. The next one, what's different about this one is we're actually dividing, all right? We're taking our input and we are dividing it. Going back to our review and some items, right? What do we know is bad here? Well, division by 0. So 0 is actually a bad value, right? But we can put in some negative values, we can put in some positive values and kind of see what happens. If I put in a -2, we're going to end up with a -1/2. If I put in a -1, we're going to end up with a -1. If I put in a positive 1, right, 1 over 1 is 1. And if I put in a 2, I'll get 1/2. All right, so there's basically our data points at the moment. So the ones that are easy is we got -1, -1, and we got 1, 1. It looks like we got 2, half, and we got -2, -1/2. Now it's very hard to understand what's happening with that crazy thing. So let me give you some inside information. Let's go ahead, right, and see what happens between -1 and 1. All right, and we are symmetric here. If we replace x and y with both double negatives and to multiply it by -1, we'll get the same thing back. So whatever I do on the positive side has its symmetry around the origin with the negative side. So I'm going to take advantage of that. So what happens if I put 1/2 in there? Let's let x equal 1/2. Well, this becomes 1 over 1/2. which is 1 divided by 1/2, which means this is 1 times 2 over 1, we end up getting a value of 2, right? If I try putting 1/4 in there, right? 1 divided by 1/4 is basically 1 times 4 over 1. We end up getting a 4 there. Negative 1/2 would be -2, and negative 1/4 would be -4 because of the symmetry about the origin that I kind of threw at you there. So here's how I can look at this graph. When we're at half, we're at 2. When we're at a quarter, we're up here at 4. And you can start to see, right, remember division by 0 is undefined, but as I get closer and closer and closer to 0, the graph, right, you can even see it in the little things here, right, the graph is going to steadily be going upwards towards infinity. And then the same thing down here, right, -1/2 gives us -2, -1/4 gives us -4. So in this direction, right, the graph's going to be going there. We call this type of behavior, this ripping apart that you're seeing, we call it a vertical asymptote. And notice it's occurring where that division by 0 is occurring, x equals 0. So what about when x gets bigger this way? Well, again, because of the symmetry, whatever I do on this side will have its mirror image over there. So let me kind of do some more x values. Let's put in a 5, right? Well, if I do 5, I get 1/5. If I would do 8, I would get 1/8. So my fractions, 2, 3, 4, 5, are getting smaller and smaller and smaller. So this graph will never cross the x-axis because my fractions just keep getting smaller, and then there'll be a mirror image of it on this side over here, right, if we double flip, right, because of the symmetry about the origin. All right, and there's basically a graph of 1 over x. It's got two asymptotes, a vertical asymptote at x equals 0, and a horizontal asymptote, right, a ripping apart of the graph at y equals to 0. So very unique feature. We will see this a lot more in chapter 5, but we already had kind of seen it in chapter 1 when we were solving things with x's down in the denominator, and graphically what we end up having is a ripping apart of the graph. We know we're undefined, we know we're not in the domain, whatever the case might be, but we definitely have a ripping apart in the graph. And so that might be the first time we do that. Of course, now I invite you, break out your busting calculators, right? There's the ground and pound way of showing these graphs. You can verify it with your graphing calculator and use the technology and instant gratification. All right, so that wraps up 2.1. We're done. I will talk with you guys in the next section.